to our Product Safety Certification for North America webinar. Thank you for joining us today. This webinar is being given by MET Laboratories. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, Korea, and Italy. This webinar will run about 30 minutes with an additional 15 minutes for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your control panel. We will attempt to answer all questions at the end. Today's webinar is being presented by Roland Gutsky. Roland is MET's European Business Development Manager. At this point, I will hand over the presentation to Roland.
Thank you, Barnaby, and thanks to all of you who are attending. As Barnaby mentioned, I am the European Business Development Manager for MET Laboratories, and I primarily work with our partner labs that use MET to offer North American approvals for their clients in the area of product safety testing. I also work directly with our clients that want assistance with either North American product safety or NEPS testing, EMC, environmental, or military testing. This presentation describes the requirements for electrical products used in North America and the process by which those requirements are met. As the requirements for Canada are nearly identical, we are going to consider them as the same for the purpose of this talk. If you are invited by one of our partner labs to attend, please follow up with that partner lab if you want to pursue a program of testing and certification. And a little bit about MET first. I'll give you a little bit of background about us. In 1959, the founder of MET Labs, Leonard Fryer, discovered there was a need for testing large electrical distribution systems for utility companies. He spent the next several years working with these companies up and down the east coast of America to provide this testing. As time passed, he began getting inquiries from western states to test electrical products. At that time, there weren't any regulations at the national or federal level regarding workplace safety, and each state had its own set of requirements. This meant that if you wanted to sell your product in Oregon, there was one set of rules. Ohio and Florida might have different rules. In 1970, OSHA was established to handle, among other things, the question of product safety in the workplace. This event triggered a series of other events which were, over the next 18 years, to eventually create the NRTL industry. We'll talk more about that in depth in a few minutes. In 1989, MET was recognized as the first NRTL, entering the product safety market along with the likes of UL and Factory Mutual. MET grew very rapidly over the next 10 years, expanding from one person involved in product safety to a group of nearly 25 people. Near the end of the century, MET opened its first offices in California before expanding into Asia in 2006. Since then, MET has continued to grow, opening a second lab in California and another in Texas. In 2012, I was relocated to Italy to start our European operations. Here is where we are located in America. Baltimore is our headquarters. The lab in Raleigh is actually a franchise location that was our very first partner lab, and it was started by some former UL employees. At present, we maintain engineering in China and sales support offices in Korea and Taiwan. As I mentioned, I maintain an office outside of Milan, Italy, where our main function is to support the efforts of our partner labs in the UK and on the European continent. Here is a map of where you can get the MET mark in Europe today. We are constantly adding new partners, the most recent being VDE in Frankfurt, Germany. If you work with one of these labs and are new to North American approvals, they can help you get what you need. All the work that they do with MET is in the background. Your engineers, the locations for testing, and your local support remains exactly as it is. They just help you to get the marks that you need to sell your products in the U.S. and Canada. Now that you know a little bit about MET, we'll talk about the NRTL program specifically. What exactly is an NRTL? NRTLs are independent third-party testing laboratories that are recognized by OSHA as capable of providing testing and certification for products entering the workplace. The standards that are used in this testing are developed by American-based standards rating organizations such as ANSI, AAMI, and UL. Section 1910.308 is the part of the Code of Federal Regulations that requires that all equipment used in the workplace bear the mark of a nationally recognized testing laboratory. Now, although the original rules gave two examples of these organizations, UL and Factory Mutual, they did not include a process by which another lab could meet these requirements. METLab's founder, Len Fryer, filed suit to have that language removed. And in 1983, a court ordered references to UL and Factory Mutual be removed. Another 5 years passed before OSHA, by direction of another court order, formally established the guidelines to recognize laboratories. MET, as it would follow, became the first lab ever to be audited by OSHA. It was granted official NRTL status in 1989. Incidentally, UL did not gain NRTL status officially until 1995. So what does certification really mean? There are basically 4 points to consider. The first is that a qualified and recognized lab, an NRTL, has determined through testing that a product meets the requirements of an applicable product safety standard, and the lab has issued a certificate to that effect. Third, it means that the manufacturer can place the mark of that laboratory on the product, announcing that it is compliant for the workplace. And finally, it means that the product is monitored for continued compliance to the standard to which it was evaluated by regular inspections where the product is tested and labeled. One of the most frequent questions I get is, does my product require certification? As I mentioned before, the law requires that all products used in the workplace must bear the mark of an NRTL. Unlike Europe, self-declaration is not sufficient to meet this requirement. In addition to CFR 1910, there are other market forces at work which deem product safety testing mandatory. These include, but are not limited to, insurance regulators and buyers. In America, there are hundreds of national retailers, including Best Buy, Home Depot, Target, Sears, Walmart, and many, many others. Over time, these companies have adopted the same rules and require any product sold through their outlets to bear an NRTL mark. While the law and program legally apply to the workplace, almost every major retailer has this same requirement. Why? Basically, it's a question of liability. I say it pretty frequently that the only thing that you will find in greater abundance in the United States than guns are lawyers. And there are a few companies who are willing to put a product on their shelf that has not been tested. This is likely the second most commonly asked question, and the answer is no. UL is very well known in the marketplace and is associated with product safety testing probably more than any other lab in America, largely because of their involvement in the standards writing process. And while many of the standards that OSHA has recognized are prefaced with UL, such as UL 6950 or UL 61010, they are just one of many organizations that write standards. In fact, today UL is actually two separate and distinct organizations. There's the standards writing business that operates as a nonprofit, and then there is UL Test Labs, which is a for-profit concern. So that gives you a basic understanding of the history of the program and the legal requirements. Now, what exactly happens during the testing and certification process? Safety standards address 7 areas or hazards that can exist with the use of electrical equipment. Safety standards exist to ensure that, as much as possible, these hazards are mitigated. Obviously, with electricity, there can be shocks to the user or problems caused by short circuits that can result in electrocution and fire. But there are also mechanical tests that address things like sharp edges or the ability of a finger to contact high voltage inside of an enclosure through the vents. In addition, there might be radiation concerns with things like sound, infrared, ultraviolet, invisible light. Lasers, for instance, pose their own set of hazards, and rules apply to deal with equipment containing them. Finally, there are chemical hazards, which can result when there is contact or inhalation of vapors or fumes. The evaluation is composed of 2 main areas. The first is a constructional review. This takes place first and considers the enclosure as well as the layout of the components and materials. Standards also dictate how information must be presented in documentation, including user manuals and service guides. During the constructional review, an engineer will go clause by clause through the standard and note whether the clause is applicable and whether the equipment passes or fails the clause. Any nonconformities are noted and included on a document called a findings report. At the end of the constructional review, the findings are presented to the client, and they are given an opportunity to rectify the nonconformities. During the first stage, the engineer will also develop a test plan that will be carried out to test characteristics such as thermals, dielectric strength, input current, and abnormal tests. During the second stage, the actual testing of the product is carried out. If a product fails a test, this is relayed to the client, and they take corrective action. As you can see, this is an iterative process most of the time. Rarely have I seen a product enter and exit the process without some nonconformity coming to light. It could be minor, such as missing text in manuals, or it could be something major, like the product burst into flames during one of the tests. One very important product of the evaluation is a table called the List of Safety Critical Components. A safety critical component is one that the engineer has identified as impacting that product's ability to meet the requirements of the safety standard. It might be the flammability rating on the enclosure. It could be a safety switch or batteries. It could be any number of components. This list is very important because it constitutes what are the controlled components of the product. These are the parts that, if changed, are going to require the involvement of the test lab. Anytime a component on this list is altered, it must first be evaluated by the lab to ensure that the change is not going to render the product unsafe. Every NRTL has a process for handling changes to safety critical components, and we'll talk about this a little bit later. In Europe, very often manufacturers will want to use components that have only a CE mark. This will not be adequate for products that enter North America. If a product is on the list of safety critical components, they must have an NRTL listing or recognition. A CE mark is not enough. In fact, the CE mark means nothing in the United States. So what if there is no way around it? What if you have a custom-made transformer or some other component that is custom designed for your product? You may use uncertified components, but it is going to require additional effort and cost. NRTLs are required to first evaluate that component during the initial project and then reevaluate that same component every year to ensure that it continues to maintain the compliance of that product. Depending upon the component, this may or may not involve actual retesting. If the NRTL report indicates that a component requires annual evaluation, a factory inspector will collect a random sample during one of the follow-up inspections. At this point, you might be wondering, what inspections? Well, unlike Europe, OSHA requires that every product bearing an NRTL mark be inspected at its point of final assembly and testing a minimum of twice per year. The first time you list a product, the NRTL is going to visit your factory and inspect your procedures and manufacturing. They're going to ensure that you have a minimum of written policies and procedures to make that product consistently. This is called a pre-certification factory inspection, or PCFI. If your company has an ISO certification, this is likely going to be simple enough, as what the NRTL is going to be looking for are the same items that are required by the ISO standards. The NRTL will look at how you document changes to the product, how you check and quarantine incoming materials that are out of spec, and how customer complaints are handled and resolved, and so on. Once the PCFI is completed satisfactory, the manufacturer can mark the product. During the follow-up inspections, the NRTL will also ensure that any testing that is required in the NRTL report is being conducted on site and records are maintained. Almost all equipment that connects to mains power will require dielectric strength and ground continuity testing. Also, the inspector will compare your list of safety critical components to a random sample pulled from production to ensure that the same components are in the final product. All of these procedures are requirements of OSHA and protect the integrity of the NRTL mark and the program. By applying an NRTL mark, you are stating that your product meets the requirements of the standard, and the mark is proof of that. In addition, you are separating yourself from others by announcing that you are committed to producing safe products and that your quality is monitored by a third party, in this case, the NRTL that holds the listing. This is an example of a label that would be affixed to a compliant product. The NRTL is obviously indicated, as well as the traceable file number. Traceability is a key component to the program, and that number gives anyone the ability to determine whether or not a product is compliant through the online databases of each NRTL. The C indicates that the product is compliant for Canada, and the U.S. is for the United States. The label may also list the standards to which the product complies. Not all products are tested in laboratories. There are programs that exist for testing at manufacturers' labs. There's a number of scenarios where this applies. This is often common with huge companies like beverage makers who manufacture their own vending machines in a wide range of configurations. These companies will often have their own labs that are audited by NRTLs under one of these programs. That way they don't have to send their equipment to a lab for testing. For products of a one-off nature or that are just simply too large to send to a test lab, there's a program that allows for equipment to be tested in the locations where they are installed. These special situations are addressed with the use of field labels. So what if my product changes? We and all the other NRTLs understand that your product is likely to change at some point in time, or that you might move to a new location. Anytime your NRTL report must change, a PAR must be completed. The most important thing to remember about PARs is they must be dealt with before you make any changes. If an inspector shows up and finds a component in your product that is on the list as being safety critical and it doesn't match what's in the product, you are possibly going to be prevented from labeling that product until the change has been assessed. Similarly, if an inspector shows up at your address in, say, Paris, France, there's a sign on the door saying that you've moved your factory to Madrid, you're going to be out of compliance until the NRTL evaluates the new location with a PCFI. It's also worth mentioning at this point that if your product requires production line testing for dielectric strength and or ground continuity, equipment that you use to perform those tests require annual calibration. If you don't keep up the calibration programs, you could wind up not being able to mark your product until the calibration is performed. So why do we do all this? Well, obviously, the first reason is to comply with federal law. And aside from the market forces that I talked about, there are other authorities having jurisdiction over installations of equipment. Authorities of having jurisdiction exist at all levels of government and could even be state and local building inspectors. All of these are likely going to have requirements that include NRTL certification. The reason these people exist is to ensure that the local and federal law is respected, as well as to ensure that installations are safe and that materials and equipment comply with the rules. The points that I hope you take away from this presentation are that OSHA is in charge of the program, not UL. OSHA recognizes labs and standards as meeting the federal requirements. NRTLs are the labs whose marks meet those requirements. Equipment and material that meets the requirements of the standards are marked and listed, and all the standards in the program are developed by U.S.-based standards organizations. Throughout this presentation, I had mentioned that OSHA requires testing to be performed with the involvement of an NRTL. Over time, OSHA, as well as most of the rest of the industrialized world, has recognized that companies now operate and sell globally. To facilitate this, the IEC CD created the CD Scheme, which allows manufacturers to get one report from a participating lab that will be accepted by more than 50 countries. There are often national deviations that must be taken into consideration, but this system is a huge leap forward over what previously existed. The one drawback of the OSHA system is the requirement that a product sample must be sent with the CB report. This is often not practical given distance, shipping costs, or in the interest of time. To relieve this burden, MET developed a system which was approved by OSHA to work with other qualified labs around the world. Basically, we qualify these partner labs through a quality and technical audit. Once a lab successfully completes the audit, we are able to then accept the reports without the need for them to send a product sample. The result is that you, the manufacturer, continue to work with your local lab, and you're able to gain access to North America easily and affordably. If there isn't a harmonized standard for your product, we offer options that will still allow you to use your local lab. If you contact one of our partner labs, they can explain this, or you can contact me directly for details. Here again are some of the partners that we have around the globe. If you were referred to this webinar by one of these labs, please contact your representatives at that lab to talk about a test program for North America. If you'd like to work with one of these labs and you don't have a contact, let us know. We'll put you in touch with one. Just send an email to info@metlabs.com. Finally, there are a few standards of note that have either recently changed or are in the process of changing. One of the most important updates is that OSHA is now accepting the latest AAMI standard for medical devices. This is the U.S. standard that is based on the IEC 60601 3rd edition. I probably had more inquiries on this topic than any other in the last 2 years. Now that it is accepted, OSHA is working with each NRTL to have it added to their scopes. The second edition of 62368 was released last year, and the United States and Canada are working together on the national deviations. We should see something on this later in the year. Finally, with respect to hazardous locations, UL 913, which deals with intrinsically safe devices, is in a unique position right now, as both the 5th and the 7th edition are currently accepted. After July of 2016, however, only a 7th edition will be accepted. And this latest edition is now harmonized with the IEC 60079 series, which is what IEC EX and ATEX are based on. Thanks very much for your time today. I hope you found this information useful, and at this point we are going to open up the discussion to questions, and I think Barnaby will be moderating moving forward. Thanks again.
Yes, thank you, Roland. That concludes the presentation portion of this webinar. A copy of the webinar will be available on metlabs.com. We will send a follow-up email with a link to this file. Now, as Roland said, we will answer questions. If you have a question, please type it in the questions area of your control panel. For questions we can easily address now, we will read the question aloud, then give the answer. Roland, do you see the questions in your control panel?
I don't.
Do you have the questions panel in your area there?
No, I have webcam, audio, dashboard, attendees, polls, and chat.
Okay, I will go ahead and read the questions aloud. And then if you want to take a shot at answering them, that would be great.
Sure.
Some of these you may have already answered in the webinar, but if that's the case, you can just reiterate since these questions came in during the webinar. So the first question is it compulsory for products being sold into North America to have any form of NRTL mark?
What I always tell people is that the only thing compulsory in life is death. It used to be death and taxes, but if you don't mind going to prison, even taxes are optional. Products don't necessarily have to have a mark to cross the border. Where you're going to run into resistance is when people go to purchase those devices. Employers in the United States are aware of the law, and they understand that anything that they buy to use in their business has to have an NRTL mark. So you're going to find it very, very difficult to sell a product that's going to be used in a workplace in the United States just because the employer is responsible for complying with that law.